Okay, so we look at light, and the question that we have says a ray of light travels from air into water, which basically means we have a ray of light moving from a vacuum, which is air, going into water, and we have been told that it travels at an angle of 40 degrees. Okay, 40 degrees between the normal and the incident ray. So it's very important that we know where the normal is, we know where the incident ray is. It will be very easy for us to know where the angle is, because if we don't put the angle correctly, we're going to get everything wrong. Okay, so this is our normal. This is our normal right here. So we are going to have we're going to have an incident ray coming like that. Okay, okay, something like that. So what we have here, this ray is an incident ray, and just remind ourselves, this is air, okay, and this is water. Okay, these two are two different mediums. We can differentiate them even in terms of course both are fluids, but we can differentiate them in terms of the difference in density. Okay, so we are told that the angle between the normal and the incident ray is 40 degrees. So the angle that is here is 40 degrees. Okay, so the other information that we are given is that if the ray produces an angle of refraction of 29 degrees, calculate the refractive index of water as well as the critical angle of water. So from this part here that we have, this part here, the angle of refraction, okay, angle of refraction. So even before we tell ourselves or we show ourselves where the angle of refraction is, it's very important that we understand the difference between refraction and refraction, because if we get them wrong, we're going to put the angle in a wrong place, and that will make everything difficult. Okay, so when you're talking about if this is let's say this line separates two mediums, okay, and let's say this is something like the normal. Okay, so when you have a ray of light coming like this, then it bounces back going like that. It's still in the same medium. If this was air, okay, and this is a certain medium, let me just say medium X, if this ray of light bounces back, what this phenomena is described as what? As refraction. Okay, diffraction. But if this ray of light comes in, okay, comes in at a certain angle, it comes in like that, goes into the medium X, that is refraction. Okay, so refraction, it's like light is bouncing back. Refraction is a bending of light. Okay, so it basically means the angle that we are talking about is inside the medium, which is what? Which is water. Okay, and the angle we have been given, which makes things easy. um, the angle I've been given as 29 degrees. Okay, again, maybe someone will be like, okay, where should I know? Is the angle supposed to be here, or maybe here, or anywhere? The angle is always between the ray in question, as well as is between the normal and the ray that you're talking about. So if you're given an angle here, don't use the angle that is here to do some calculations. Subtract from 90 in this case to be able to get the right angle. So let's just say we were given something like a 50, okay, 50 degrees, meaning we know to say 50 plus 40 adds up to 90. So, and of course you're not supposed to use 50, you're supposed to use 40, because we're looking for the angle between the ray itself and the normal. Okay, so the angle that we have here is a 29 degrees. This angle is a 29 degrees, like that. Okay, so now we go to answering the questions. So the first question says we need to find the refractive index of water. So from Snell's law, we know that n is equals to sine I, okay, divide by sine r. Okay, so the I here is this one here that we have. Then the R is this one. So we're just talking about sine 40 divided by sine 29. Okay, we go to our calculators. We say sine 40 divided by sine 29. What we are going to get is a value that is 1.325 85573. It keeps on going on and on and on, but I'm going to round off to two decimal places. That would be 1.33. So the refractive index of water is 1.33 in this case. Okay, so going to the next part, we need to find the critical angle of water. Okay, so before you even answer, it's very important that you also understand to say what does it mean us having a critical angle. So when you are talking about a critical angle, I would simply say the critical angle is basically the incident angle when R is equals to 90 degrees. So when when the refracted angle or angle of refraction is equals to 90 degrees, the critical angle is equals to what? The angle of incidence. Okay, so the angle that you have when R is 90 is what is called the critical angle, and that is what we want to find in this case. Okay, and from Snell's law, we know that n1 sine theta is equals to n2 sine theta, like that. Okay, so in this case, our n1 is the refractive index of water, which we have already found, which is 1.33. Then n2 is the refractive index of air, and in this case is what? It's 1. So we also need to understand that different mediums have different refractive indexes. Okay, and in this case, if just let's just say the other medium was there are different mediums that we can use. It can be glass, it can be a diamond, or anything else. For glass, it's 1.52. For diamond, is 2.4, something like that. Okay, so they are just different refractive indexes. So here, so it basically means our n1 is what we already have. Our n2 is 1. Then at this part, what about the sine theta and the other sine theta? What happens to it? Of course, this is a 1 and that's a 2 there. So I'll start with the other side of the equal sign. I'll write this as my n2, then this as my sine, right? Sine 90. Okay, because that's what I'm basically looking for. We only have the critical angle when sine r is equals to what? 90 degrees. Okay, so we're going to have our n1 here. So instead of me here writing sine I in terms of sine angle of incidence, I'm going to write sine C, meaning the critical angle there. Okay, so when you go to your calculator, this part that has sine 90, sine 90 is basically a 1. So what you're going to have is n1 sine C is equals to n2, because you said n2 multiplied by 1. So what we do here is we make sine C the sub of the formula. So that would be sine C is equals to n2 divided by n1. Okay, our n2 is 1 divided by our n1 is 1.33. So when you go to our calculators, we say 1 divided by 1.33. What we get is sine C is equals to 0. Okay, 0.751879699. Okay, so meaning our C as the critical angle is equals to sine inverse of this same value that we have here. Okay, 699, like that. Okay, so what you're going to have at the end of the day is a 48. So the critical angle will be equals to what? Will be equals to 48 point. I'll leave it to one decimal place. 8 degrees. So that is basically how we come up with a critical angle. Yes. So it's very important that even as we start to answer the question, we understand where the question is coming from, we understand the meaning of the terms, and how the terms that we have are different from each other, and even the terms that we have not brought in this the terms that are not in this question. Yeah, so thank you very much for watching.